Hi, this is Fitton, and I'm here to talk with my statistics students on January 22nd, 2016. Before I get started with the PowerPoint, I want to point out to you the things that I have that are going to run on this computer. This is a Windows desktop. This is PowerPoint, which we're going to be looking at. I also have the File Explorer here. We're going to be looking at files that are on a DVD. I have a browser in which we are going to run the program StatCrunch. I have a Word document because I'm going to be pasting things from StatCrunch into a Word document. And this is Camtasia Studio, the program that I am recording this video with. So let's get started with the PowerPoint. This is partly made by me and partly by the publisher, Pearson. It's a whiteout day. This is the cover of the book, and 2.1 is the section that we started with on Friday last week. And as I told you then, what we have here is mostly vocabulary words that are essential to our study. We need to know the meanings of these words the way that we know algebra, simple operations in algebra, because the distinctions between qualitative and quantitative variables are absolutely going to determine the statistical methods that we use for the rest of the semester. Then, in the quantitative variables, as we talked about last week, we have discrete and continuous variables. Here we have a chart, this is right out of the book of course, that shows how these variables relate to each other. Variables generally, which are facts that we might observe in anything that we're studying, a person's height, the amount of money a business makes, somebody's favorite color. Variables are divided into qualitative or categorical variables and quantitative variables. Quantitative variables are things that you can, for instance, do arithmetic with, take an average of, and so forth. Qualitative or categorical variables are things that you don't do arithmetic with. You don't do arithmetic when people discuss their favorite colors or sports teams. You can say how many like what color and how many like what sports team, but that's a different kind of thing. The variable itself would be the color or the sports team that a person goes for. Then among quantitative variables, we have things like how tall somebody is. That would be measured. How much someone weighs. That's a continuous or measured variable because any value, any real number within a certain range could be a person's weight or height. Discrete, that's the stuff that you can count. How many dollars, how many free throws, and so on. Last item here, data. Well, the values of each of these. Okay, here's a problem from the book in which we are asked to consider this collection of data and to describe each item in it as qualitative or quantitative. So, ranks, those are always quantitative. They're also ordinal, as we will see in a moment. Names of dead people who are still making a lot of money, those are categories. Elvis had 45 million that year. The year was 2005. Charles Schulz, the fellow who wrote Peanuts stuff, his earnings were 35 million. Theodore Geisel, Dr. Seuss, 10 million. Here we have in problem 13 information about smartphones. The phones themselves are the categories. The ranks, those are ordinal data or discrete quantitative variables. Internet browser, yes, no, true, false, up, down, those are categories also. Does it or does it not have an internet browser? And aren't we glad those days are far behind us? Now, weight. Let's take the weight of the top telephone here, an Apple iPhone, 4.7 ounces. We know from our experience in measuring things that what that really means is anything between 4.65 ounces and 4.75, but less than 4.75, because otherwise we would have rounded up to 4.8. So these don't mean exactly 4.7 ounces, nor does it mean exactly 300 minutes. These appear to be rounded by tens. These appeared to be rounded by tenths. And in both cases, these are things that were measured. Time is always measured, and time is always a continuous variable. Here in problem number 14, we have some remarks about ordinal data. I'd like you to think about that one on your own. The homework for this section, all of the odd problems, please. Please bring any questions that you have about the odd problems. Say you do a problem and you get a different answer than what they have in the back of the book. Bring those problems to class, and then we'll see. That's the end of section 2.1.